Good morning. Thank you for joining in. This is Marcel Hergaarden and Kratz from Kratz. This morning with a webinar about Redis storage and the solution that Kratz has built to roll out and maintain Redis storage. So first of all, we would like to give you a little update about the product, a brief overview, what it is, what it does, and then we'll pass on to Kratz for a technical explanation about their solution and how this fits in with Redis storage. So my name is Marcel Hergaarden. I'm Solution Architect for Redis Storage based in the Benelux. And besides me is Kratz from Kratz, a business partner of ours who has created the solution to enroll Redis storage in an easy way. So Redis storage, the agenda for today, a short introduction about Redis storage. We're talking about the Kratz business solutions, a partner of ours and what they deliver. And Kratz has a technical explanation about what their solution does, how it works, etc. So that's the agenda for this session today. Okay, about Redis storage. What's Redis storage? It's an open, extensible, scale-out, software-defined storage solution. So it's not a box with disks or a storage hardware system. It's a software-defined storage solution which can run on top of x86 hardware virtualized systems, but more about that later. You can run it on-premise, that means in your data center or in your company. You can also run it in virtualized environments, that means you can run it inside Red Hat Enterprise Virtualization. And you can also run it on VMware vSphere 5.1, and you can run it in public cloud environments, like for instance Amazon, AWS, and there you can start your Amazon machine image, Red Hat storage, and build the same situation just like you do on-premise in virtualized and also in public cloud. The product is based on GlusterFS, and GlusterFS, more details about GlusterFS can be found on gluster.org, which is the upstream website from the Redis storage product. Then a little something about the key benefits of Redis storage. Those benefits are you can deploy it anywhere. Because it's a software solution, you can run it on-premise, private cloud, public cloud, and even hybrid. That means a combination of both. You are able to dramatically
this is Anna.
You choose the infrastructure, x86, virtual, or public cloud. And you can also use it as a foundation for big data. We have a scale-out storage solution for both file and object data. And with object data, we mean that you have object-based access. And you can talk to the storage system, not as if you connect to a file system, but it's based on HTTPS with a certificate, and then you can put and get your objects in and out of the storage. We're also open and extensible. And we are open in the way of we are an open source solution. There is nothing secret. There are no special software tricks or closed things. It's all open. We make use of open standards, so you can create your own extensible modules. You can run apps co-resident eventually. So in that way, we are open and extensible. Then Redis Storage 2.0 in the web in a nutshell. Redis storage is to be installed on x86 server hardware, and that means you can install it on almost every brand vendor type of storage, the one you want to use, the one you have already in your company, the one you prefer to use. There is also a hardware compatibility list. You can look it up on www.redhat.com/hardware, and there is a list of supported hardware. It's also extremely flexible and easy to use because you can scale out, you can also scale up. You have several capabilities to manage the storage. So in other words, you can create a powerful, massively scalable and highly available file and object storage within minutes, especially when you use the Kratz solution, the one Kratz built. We will talk later about this and let you all about all details. Well, and I've said it a few times already, you can use it inside your data center, you can use it in the public cloud, and also in a hybrid setup, and that means it's a combination of both. And that way it's possible to share your data, or move your data around from on-premise to cloud, and you're very flexible by this principle. Okay, then let's have a look at how it's built. How is the volume setup created inside Redis storage? First of all, we make use of standard x86 hardware boxes. So we have standardized server systems here, and these server systems run an operating environment. And this operating environment then, in this case, is Redis storage, the operating system, and it will run on a mirrored disk. We would prefer to have this run on a RAID 1, and then that's only for the operating system part. Besides this, we make use of a preferred RAID 6 disk group, so that those are the disks which are inside the server system. It could also be an attached storage, a direct attached storage, which brings RAID groups to your server system. On top of that, we have a logical volume management layer, so we create logical volumes on that, and out of that we create our bricks. And the bricks are the building blocks to create a Redis storage cluster volume. So this is how it's built up. You have your server. Server runs an operating environment, and we prefer to have this on a mirrored environment, mirrored disk. On top of that, there's a RAID 6 disk group. RAID 6 is preferred for Redis storage. That's put into an LVM configuration, and those LVMs have logical volumes, and those are formatted with XFS file system, and those are the bricks. And with these bricks, we build our Redis storage cluster volume. And you can add in servers on the fly, so you can expand your system, and this can all be done online without any downtime. So if we have the volume in place, then how can we access this volume? We have several protocols to connect to the volume. The native one is our fuse connection method, and that's also called GlusterFS native fuse connection. The advantage of this one is that it has built-in load balancing, it has failover capabilities, and that's all in the fuse connectivity. We can also connect by using the Samba share, SMB or SIPS connection. And that means that you can connect your Windows systems to Redis storage by using this SIPS connection method, or the SMB server message block connection method. Then there is another method to connect, and that will be the NFS, and that's a network file share as known in legacy Unix systems. And it's also possible to use this one to connect to your Redis storage cluster volume. And last but not least, a very important one for the OpenStack also, it's the Swift connection method, and that's based on the OpenStack Swift. So that's how we connect to Redis storage. Then I have a few use case examples for you. Where can you use Redis storage? Well, you can use it as a store for unstructured data, and that can be all kinds of data except for database data. You can also use it as a store for ref virtual machines or ref images, and that means that virtual machines inside ref can live on Redis storage, bringing also the capabilities to run it on-premise, in the cloud, etc., and also move your images between both. Another example is that we can act as a store for backup and archive data, and that's where we partner with existing backup and archiving products like Commvault, Simpana, and also SEP backup, SEP backup. Those are products we're partnering with to deliver backup and archive solutions combined with Redis storage. And when we look at OpenStack, we can also facilitate Cinder, that means block storage, and therefore we use the native connection method Fuse. We can also act as a glance inside OpenStack, and glance is used for images. And also the connection method here would be the native Fuse connection. And then the other one is Swift, and Swift means object-based connectivity inside OpenStack, and therefore we use the Swift connection method inside Redis storage. It can also be used as a broadcast and multimedia content store, and we have examples of this here in the Netherlands, a company who actually uses this, and probably Tico can spend some words on it later. It can be used for big data purposes. This is actually a sweet spot for Redis storage also. And another example would be a picture data store, very big images, like for instance medical purposes, the photos made in an hospital. They need to be stored somewhere, and they can become very large, and therefore we can also act as a extensible picture data store. Easy to scale out. So that was about Redis storage in short. A short introduction, a brief overview of what it is, what it does, and then I would like to update you about what Kratz is doing together with Redis. And they have a so-called closed-loop deployment of Redis storage. Well, what is it and how does it work? It's delivered as an appliance, as a software appliance, which can run on a Raspberry Pi, for instance, but can also run on a virtual machine image. And that can be on VMware or wherever whatsoever. It's just a software appliance who needs a host to run on. And it can easily be a Raspberry Pi or a VM. It brings you easy provisioning of large Redis storage clusters. And that means if you have 4 nodes or if you have 40 nodes, it's no problem at all. The solution will take care of it. It will roll out the Redis storage on your hardware, fully automated, and brings it also into monitoring. And when it does this, it makes use of the closed loop setup principle. And that means while Redis storage is installed, it's being checked if everything is okay, if everything runs fine, if there are no errors made in the configuration somehow, there are certain checks in it. It prevents to have human errors like typos. Typos are easily made when you do everything on the command line. And then you can easily touch a wrong button and then things could go wrong. So therefore it prevents you to do so. It's fully automated, scripted, etc. So that's in short about the solution that Kratz brings. Tycho will tell you lots of details about it, and you can also ask questions by using the chat window. Okay, so this is what it brings. You don't have to have any technical knowledge to roll out Redis storage, to configure it, to bring on the volumes, etc. It's all being done for you by the appliance that's being delivered by Kratz. It enables you to have an easy setup, but also expansion of Redis storage clusters. And that means that if you have an existing configuration and you want to add in new servers, the appliance can take care of that for you. And again, you don't have to have your typos or doing things wrong or don't remember exactly how it went the last time, and then the appliance will take care of this in a safe way. So I said, no human errors. It's an open source solution also. It's built on open components. So there are no secret things. It's all open source, just as our product. And therefore you have no vendor login in the solution. It comes as an appliance, and that means a software appliance, and it can run on a Raspberry Pi or a VM. It just needs a host to run on. It's also future-proof this way, because we use, again, open standards, open source software, no secret things, no logins, so you're safe with this product. And when the installation has been done, there's also a monitoring part included. And that's also brought in the appliance by Kratz. And Kratz has a solution for that based on Nagfish, and you can easily check your nodes, see if everything is running fine, if there are no problems with disk, CPU, or whatsoever, fans. When there is an issue, it will immediately be visible in this overview, and you will know if there is something wrong. So that's the monitoring part. It's also included in their solution. If you want to have more information about the solution, then you can always visit the website of Kratz, and that's www.kratz.nl, and you can go to the storage tab there. Because if you go to the storage tab, then there are certain articles about the solution available in English language. The site is also in Dutch, but at the storage tab you can also visit the English items there, which gives you some explanation, use case, and examples of what the product does. And now I would like to introduce you to Mr. Tycho Kratz. Tycho is technical consultant at Kratz. He has been there from the beginning of Redis storage. We worked together with a customer of ours where the closed loop appliance also has been used very successful. The customer is very happy with it, and it runs smoothly and does everything we would like to have. So please let me introduce you to Tycho. Tycho of Kratz, and he will tell you about the solution they have made and they maintain. And also, if you want to contact Tycho, his mail address is shown here in the slide. It's tycho.klitze@kratz.nl. Okay, Tycho, the floor is all yours. I'm sharing your presentation, so you can go as you like.
Well, thank you, Marcel, for this very good introduction of course, Red Hat Storage, which is your business, and the provisioning tool, which is our business. I would like to address two more points. One about the appliance, and one about the use case that we have at a customer. And yeah, those points are I think very interesting for eventual future interested customers that could roll out cluster storage or Red Hat storage. First of all, I would like to show you how easy it is to get your running copy of Red Hat storage on premise. The only thing you have to do is contact us by phone, by email, or whatever. We will talk about what kind of hardware and what kind of needs you would like to have for your storage, the amount of storage, the performance that you need, etc., and also a growth path. And we will describe that in a so-called setup agreement. And based on this setup agreement, we are going to fit the appliance for you. And what the appliance basically does, as Marcel pointed it out already, is that it completely automatically deploys all the nodes of your future Red Hat storage cluster. So based on the agreement, we start fitting the appliance for you, and then we will send it to you. And the only thing that you have to do then is the deployment on premise. So you have to connect the appliance to your storage nodes and start booting them from the network, and all the installation will be done automatically. Of course, if there are any issues or any questions during the process or after the process, you can always contact us, and we will also help you remotely, and we can join in any moment to answer questions or to add extensions or to eventually solve problems that have arisen. And so don't hesitate to contact us. So this closed loop provisioning thing, what is it? Actually, it is a way of installation that we have come up with after many installations we have done in the past. Closed loop provisioning is installation with the end result in mind. So you're not only shooting information parameters to bricks or to systems, but you also check later on if what you were supposed to set up is really working. So in that way it easily helps you to consistently deploy large clusters with many nodes, because you control from a single terminal, you control all the deployment of the nodes. They are consistently set up, so because you are not doing it all by hand. Because you are doing it scripted from the appliance, it keeps you from human mistakes. And if you are, let me explain you. If you are going to install a lot of nodes, let's say 16 or 32, after a while you will really start making mistakes. And if you have to maintain 16 or 32 systems, and you can remember, or you find out later that you made a mistake on one of them and you don't know exactly where it was, you don't really have a central console to find out where the problem has arisen, then yeah, you're really going to spend a lot of time to catch up on your mistakes you made. So deploying this way is really going to save you a lot of time. It also helps you with future upgrades, because we fit or we program the appliance not only for the current installation but also for future nodes. So if you want to add future nodes, you just can add them to your existing cluster or existing Red Hat storage cluster, and using the appliance you can quickly deploy them and add them to your already operational storage. So how does it do that? Well, there are some very basic technologies in the appliance. Of course, it uses PXE to deploy an operating system over the network. Well, besides that, it has also a central console where all the system settings of all the nodes are configured. And after it has deployed the nodes, it will verify all the relevant parameters using Navios templates and show you in a simple dashboard if everything turned out as the way you expected. So what do you need to run it? We can deliver a complete platform to your location by just sending you a Raspberry Pi. We chose that platform because it's very lightweighted, and you can also use it as a monitoring system later. It doesn't need much power to run, so you won't even notice that it's there. And it can be very helpful to leave it there as a closed system to have a provisioning platform in place for provisioning future nodes. Well, of course, it contains the Red Hat Storage Server ISO, and yeah, you also need at least one node, of course, to deploy Red Hat Storage Server. So, how does deployment work out for you? Well, the only thing you have to tell the appliance is the host name of the host names of your nodes. Let's say we have an example here with 4 nodes. We call them Red Hat Storage Server 01 till 04. We give the fully qualified domain name. We provide the MAC address and the cluster IP addresses, public IP addresses, for instance, if you are using firewalling and you want to connect with some public servers, or you want the nodes to connect to public servers. And there's also maybe a management or out-of-band network that you want to use, and you can also add IP addresses for that. So basically, this is all you need to deploy successfully a 4-node cluster using the storage appliance. Immediately when the appliance starts, you can log into the storage appliance, and it will provide you with an overview of your storage nodes. And the overview is done in such a way that you can easily point out problems. For instance, if you have a problem with a fan on server number 2, the fan icon will become red and the server number 2 icon will become red. You just draw a line between the two of them and you know what the problem is. So all the relevant parts of operation of the cluster, like fans, disks, power supplies, battery backup units for RAID controllers, chipsets, chassis chipsets, and so on, but also the software and the heartbeats of the operating system, and also volume storage of your cluster volumes is monitored in this screen, and it gives you one screen with an overview where you can immediately pinpoint all kinds of problems. So you don't have to really drill down, you can immediately see what's going on in your cluster. So for that, the storage appliance, I would like to address the use case now, where we have used the storage appliance to implement 1 petabyte fault tolerant storage for a backend of a personal video recorder, which is used by our partner Glashart, which is part of KPN. And they use this as a storage backend for video on demand to 1 million households. Actually, it's a growing plan. The current size where we started was 100 terabytes with 4 nodes, and it will be soon scaled out to 1 petabyte, and we can fully do it with the closed-loop deployment tool, so that we won't make any mistakes in the future by adding nodes, because we forgot about how the installation process actually works. So, like I said, we use 4 supermicro nodes with 24 disks. We use a distributed replicated setup. Actually, we have introduced 2 fault-tolerant areas in the setup, because the storage is geographically separated. In case of, for instance, a disaster, the storage can be quickly transferred to another data center. And all nodes are connected by 10 gigabit Ethernet. Actually, this is a graphical representation of what we have installed so far. So we see in the vertical line, we see the 2 fault-tolerant areas. In one fault-tolerant area, everything can be switched off. So, for instance, if we want to upgrade, or if we want to remove a server or replace a server, or we want to expand file systems, or we want to do maintenance on the Cisco 4500 switch, we can do that all without any downtime, as long as we stay in one fault-tolerant area or in one fault-tolerant zone. So this is done for maintenance. So we have in this way we have created a highly available storage system that can stay online 24 hours a day. And when we are going to perform any maintenance on bricks, we will always have the file system up and running. So I would like to present you some performance tests that were performed with these 4 nodes. The tests we have done is to create a sustained load during 12 hours. At any time, we have between 1 and 16 concurrent FTP read sessions with random file sizes between 1 and 10 gigabyte, which represents the recordings or the films that are requested by clients or by set-top boxes at home. So actually these represent the streams. And at the meantime, we have between 1 and 16 concurrent FTP writes, which represent files or films or emissions that are going to be uploaded to the cluster. At any time during 12 hours, we have at least 910 megabytes per second of disk I/O, and these are mainly sequential IOPS, because actually transferring large files to and from the cluster is mainly sequential I/O. And this is done in a 50/45% read-write ratio. This is a graphical presentation about every brick and also the total of bricks, which provide the complete bandwidth. So on the left hand, on our left hand, we see that in red that every brick provides an upload stream of at least 100 megabytes per second. So in total that will be 400. And on our right hand we see that every brick can store at least 120 megabytes per second, which will be a total of 500 megabytes per second. And this all added together makes the 910 megabytes per second that we can aggregate at the moment with only 4 nodes. So this is a graphical representation of all the 4,600 upload sessions that happened in 12 hours. So every dot presents the average upload performance. So every dot, you see that all the dots are above at least 10 megabytes per second per transaction. Of course, there are some exceptions which maybe drop to 8 or 7, I see. But you see that at least any transaction that was made during those 12 hours was at least served with at least 10 megabytes per second. And of course, so this is actually let's see, megabytes per second. Switch to the other, yeah. So this is actually upload to the cluster. So any file that was uploaded to the cluster had always a average bandwidth of at least between 10 and 60 megabytes per file. So here we have the download performance, which is, as you can understand, much higher than the upload performance, because reading is much faster from an array than writing to it. So this also settled out in approximately 4,600 sessions in 12 hours, where the average bandwidth was always at least, as I can see, at least between 30 or more megabytes per second, and at times, for instance, around the 3,000 transaction, when the cluster was apparently quite well. It was quiet at that time. You could see that an individual transaction can at least climb up to 450 megabytes per second. So that will be for a single download the maximum of performance that you can get from the cluster. If we're going to add some more nodes, we are at the moment with 4 nodes. You see that we have almost 1 gigabyte per second to and from the cluster. Then we are going to add some more nodes, let's say 8, 16 or 32. Actually, I think the 32nd node will be installed any time soon, in the beginning of next year. As cluster scales quite linearly, with 32 nodes, we're able to create a concurrent bandwidth of 7 gigabytes per second to and from the cluster. So, which is already much sufficient for our purpose at the moment. So there are a lot of questions that we've come across from clients. I'm not going to answer all these questions, but I just want to list them to see that once you want to start a cluster or a Red Hat storage cluster to use at your site, you will see, and you will run into a lot of questions that you have about what type of hardware, about what type of layout, what type of disk platform, and so on. I would really encourage you to contact us about these questions. We can provide you with easily with answers, and of course, we're also happy to provide you with any information, and also quite happy to provide you with the Kratz Red Hat storage appliance to be able to successfully implement Red Hat storage server on your location. Well, this is the end of the presentation. I thank you very much for your attention, and I will quickly hand over the word to Marcel, and hope to see you or to hear from you anytime soon.
Okay, Tycho, thank you very much for explaining about your solution and everything you're doing for Red Hat storage. Then for our viewers, I would also like to show the website of Kratz, www.kratz.nl. And then there is this storage tab, and you will find certain information in English language here about the use cases, about the submit session that Kratz has done, and also the presentation can be found here on the website. You can download it from the website of Kratz. So we finished somewhat earlier today with our explanation about Red Hat storage and the use case of Kratz and also the appliance of Kratz and what it brings to the solution together. Okay, so thank you very much. This was our webinar for today. The webinar is also recorded, so we will provide you with a link later on so that you can watch it back if you want to. If you have questions, then feel free to contact us. You can contact Tycho directly at tycho@kratz.nl, and you can contact me at marcel.hergaden@redhat.com.